Welcome back to Mathematics Lifeline. In this video, we're going to integrate 1 over y squared times the square root of 18 minus 2y squared. Now, you can go ahead and pause the video and try this if you'd like to, but if not, I'm going to go ahead and start the solution right now. So looking at this integral, we kind of want to figure out a good strategy to use. And to me, I think the most clear strategy here is going to be a trig substitution. There are other ways we can go about this, and you'll see it here in a second, but I'm going to use trig sub for this video, just as an example. So the first thing we want to do is remember with trig sub, most of the time we're going to want our y squared to not have any coefficient in front of it. This way we can use a pretty basic substitution. So we're actually going to factor a 2 out of this square root. And when we do, it'll be 9 minus y squared on the inside, and we're going to pull a 1 over square root 2 outside. So this is the same thing as 1 over the square root of 2 times the integral of 1 over y squared, the square root of 9 minus y squared, dy. So those are equal, and now this is going to be much easier to work with a trig sub, and the reason is because the y squared doesn't have a coefficient in front of it. So we have the form of a squared minus, in our case, y squared. So when we have that form, what we do is we let y equal, it's going to be a sine theta. And in this case, our a is 3, because that's the square root of 9, so y equals 3 sine theta. And now we're going to need two things, because we still need to replace this y squared, and we also need to replace the dy. So if y is 3 sine theta, then y squared is going to be this, of course, just squaring that, it's going to be 9 sine squared theta. And then dy is the derivative of y, so that's going to be 3 cosine theta d theta. Now at this point, we have everything that we need to go ahead and make our substitution. So coming down here, we still have this 1 over root 2 on the outside, but now the inside integral has turned into, well, 1 times dy in the numerator. So that's just going to be a 3 cosine theta in the numerator. And the denominator becomes y squared, which we said was 9 sine squared theta, times the square root of 9 minus y squared. So 9 minus 9 sine squared theta. And then we can't forget the d theta. So this is our new integral here. So now we can actually evaluate this in terms of theta, and it's actually going to be pretty easy once we simplify this. So, well, the first thing we're going to do is we want to figure out how we can simplify this square root. So I'm going to kind of write this down here. The square root of 9 minus 9 sine squared theta is the same thing as factoring the 9, right? And when we factor a 9 from under the square root, it just becomes a 3. So we have 3 times the square root of 1 minus sine squared theta. And remember that 1 minus sine squared theta is cosine squared theta. So then we have 3 times the square root of cosine squared theta. And then, of course, the square and the square root we can cancel out. So the denominator, is, or this part of the denominator at least, is just going to become a 3 cosine theta. And you can see how nice that is, right? Because if this is 3 cosine theta in the square root, well, that cancels out really nicely with this 3 cosine theta. So we can actually cancel this with this. And then at this point, we'll pull the 9 out as well. So we're going to have 1 over 9 times the square root of 2. And then we have the integral of 1 over sine squared theta, d theta. Now, it may not immediately be clear how to integrate this, but we know that 1 over sine theta is going to be cosecant theta. So if we have 1 over sine squared, it'll just be cosecant squared. So now our integral looks like this. And if you remember, we can integrate cosecant squared pretty nicely, because we remember that the derivative of cotangent is negative cosecant squared. So all that is just going to be a negative cotangent. So we have 1 over 9 root 2 times negative cotangent theta, and then we'll need our plus c. But this is not the end, because remember we started out in terms of y, so now we want to turn it back into term. We started out in terms of y, now we're in theta, so we want to go back to y terms here. And the way we're going to do that is we're going to set up our triangle here. So if we set up the triangle for this problem, this is what our triangle is going to look like. If this is theta, we know the hypotenuse is going to be just a, and in our case it was 3. And we said y was 3 sine theta, which means that y needs to be over here, because that would mean that sine of theta is y over 3, and then we just multiply the 3 over. And now by the Pythagorean theorem, this leg of the triangle is the square root of 9 minus y squared. And now we can get cotangent theta, because cotangent theta is always adjacent over the opposite. So in that case, cotangent theta is going to be, so we'll write it here, cotangent theta, in our case, is going to be the square root of 9 minus y squared over y. And using this, now we can plug that back in for this cotangent theta, and we'll have everything back in terms of y, and we'll actually be done. So we have 1 over 9 root 2 times negative square root of 9 minus y squared over y plus c. And we're going to write this a little bit nicer. So what we have here is going to be negative root 9 minus y squared. And all of that is divided by 9 root 2 y. And then we have our plus c. And that will be our answer for this question. So this is really just a straightforward trig sub. The hard part is knowing to pull this 2 out of here. And then you really, even for this integral, I think there's other methods you can use. You may not even have to use trig sub. I just think it's a good example. And it does give you kind of an ugly answer, right? So you need to be confident in your method, because if you look at this, you're going to think you did something wrong. But really, that is the correct answer here. So yeah, that's all I have for this video. If you have any recommendations for future integrals you want to see, or if you just have any video ideas, let me know. If you have any questions, of course, let me know in the comments and I will answer those. But if not, then I will see you in the next video. Thanks for watching.